Well, good evening. Welcome to Space Oddities. How are you all this evening on this Tuesday evening? Thank you all for joining us so much this evening. And we've got a very, very hot day, about 37, 38 degrees here in Spain. So it's been a bit exhausting today. So if I fall asleep, please don't take it personally. Anyway, what's been going on? I hope you've all had a great week. Thank you for joining us. And we've got some interesting stuff, as always, coming up for you this evening. Joined this evening by Roger, by Daz, by Michael and Lou, in other words, the normal suspects. But we're delighted on Space Oddities to welcome for the first time as a new member of our team, Mr. John Press. So how are you, John?
I'm fine, thank you very much. It's not quite 38 degrees here, but it's not far off.
Oh, okay. So your volume is a little low, John. Let's see if I can...
So we turn that up again. There we go. How's that?
Still wow. Low.
I see we've got some money coming in.
We do.
All right. Okay.
How's that? There we go.
Let me just listen to John for a moment. Try that, John.
That's as big as the microphone will go.
That's fine. That's fine now. That's great. Okay. All right. So let's see who's hanging out with us, so to speak, this evening. Oh, Gerard, thank you so much for that. And Ian, thank you so much as well. So, guys, that's very generous of you. You know, as we always say on this show, all the money goes towards keeping the show on the road, the ship on the sea, or whatever metaphor you want to use. And it all gets ploughed back just to keep things running here. Hi. And Rachel's there. Hi, Rachel. She says she has a fussy babu tonight. So I hope he's not too fussy.
I take it that's Johnny, is it?
Yeah.
Yeah,
probably. Yeah. Gerard and Ian, thank you so much for your contributions. Much appreciated. And who else have we got here? Derek. Hello, Derek. And anybody else is in?
Alan's here as well.
Stuart's there.
Yeah.
Alan's there. Hi, Stuart. Hi, Alan. Alan says he just got back from his dark cloud observing spot in Wales. So, oh dear. So, well, what can we say, Alan? That's Wales for you, isn't it? I mean, I spent all of last Christmas in Wales, about 10 days, staying with my sister for Christmas, having a big family holiday, and it rained every single day without stopping. So I know exactly what that's like. Mind you, I did live in Wales for 25 years, so I'm used to it. So there we go. Does anybody else have I've missed here? I don't think so at the moment, but we will see. Right. So what we'll do, we'll just go through a bit of housekeeping. Then, if it's all right with you, John, we'll come back and have a chat so that our viewers can find out a little bit about you. And just when I say the normal housekeeping, that does include your option to buy us a coffee. And if you would like to buy us a coffee, then scan the QR code that's on the screen now. Any donations gratefully appreciated. And as I said again, all the money goes towards having, keeping the show on the road. You can also buy the glorious Space Oddities merchandise. And go away, Michael. And all the merchandise can be found here. A link for this should have just appeared in the chat as well. So you can click the link in the chat, or you can scan the QR code to go straight to the Space Oddities shop, where you've got T-shirts and hoodies of various styles and descriptions. So Philly boots, so to speak. The T-shirts are £25, including UK postage and packing. And that's a very good deal. And the hoodies are £40, including UK. Or was it 45, Michael?
No, it's 40, I think.
40, yes. I thought so. The hoodies are £40, including UK postage and packing. There, Daz is rather suavely modelling the 2024 Space Oddities tent.
Well stretched.
Yeah, that's the tent that we are offering now for summer camping, and nobody goes camping more than Daz.
I have my shirts made by Cameron Balloons.
Yes, so there we are. So that's all the merchandise out of the way. So next week we have, just to give you advance notice, I'll remind you again before the end of this minute. we have a rather special guest on Space Oddities. Michael, do you want to tell us about our special guest next week?
Yeah, our special guest next Tuesday is Spaceflight author Brian Harvey. Brian is based in Dublin, in Ireland, and he has written more than 20 books on spaceflight, mainly manned spaceflight, over the years, especially concentrating on the Far East, China, Japan, places like that, on their space efforts. So yeah, it's should be a good one next week.
Excellent. So there you are, Spaceflight author Brian Harvey, not the Brian Harvey from the group East 17, as we must point out to you. So if you're going to watch the show thinking you're going to see somebody from East 17, sorry, it's not him. Or at least we don't think it's him.
Not as far as I know.
Not as far as we know. No.
Mind you, if we put it on Facebook, who knows?
That's true. That's a good point. We should seriously consider that. We might get thousands of viewers as a result. False
advertising.
No. We're not going to say where he's from. If people want to jump to that conclusion, well, what are we to do? So there we are.
Yeah.
All right then.
I shall create it.
Yeah. So Brian Harvey, definitely not an E17, on the show next week, talking about his authoring of 20 books, was it, you said, Michael?
Something like that, yeah.
Something about 20 books he's written on spaceflight. So we're looking forward to what should be a very interesting chat, and we hope you can join us.
I shall create a flyer for Facebook and so forth for next week's show.
Great, thank you. Fantastic.
Yeah. Okay.
All right then. So before we go over to Roger for the usual look at the night sky and the week's gallery, let's just have a brief chat with John. So John, would you like to tell the viewers something about yourself?
Well, I live on the very east coast of East Essex, in a little town called Burnham-on-Crouch. I've lived here for 30 odd years after descending from Manchester, University at Canterbury. I've been amateur astronomy-ing for about 40 years, really. The last 10 of those quite seriously, with my income caught up with the hobby.
Right. Right. And did I read that you said you had a pulsar observatory?
Yes. I've got a nice pulsar observatory in the back garden. There's a old Celestron C-gem in there with an Evolution SCT sitting on top of it. And I mostly do planetary, but I've also got a little mount with a old William Optics Megrez 72 and an Altair camera. Do a little bit of deep sky every now and again. Right.
So are you doing more astrophotography these days, or visual observing?
It's mostly photos.
Mostly photos.
Yeah.
Well, you know what you can do. You can submit them to our weekly gallery.
Indeed.
And force some of Roger's out.
Never.
Yeah, obviously we'd love to see some of your work, John. So
not a problem.
Don't hesitate to submit them to the gallery.
Will do.
No problem at all. So yes, John has joined us. It's always good to have some fresh blood, as it were. And John might not think so at his age, but he's very much the young boy on the team. So we're glad to have you, John.
He's done quite a lot in his short astronomy career. Because didn't you found an astronomy group?
Yes, myself and a friend. 10 years ago now, we started the East Essex Astronomy Club. We started off in my friend's garage, where we did some observing. About 40 people turned up, and we've gone on since. We do a monthly talk. We're shut down for our summer break at the moment, but we do a monthly talk. I'm usually the main speaker, but we do have guests in from time to time, and we do all sorts of topics. My next one's going to be on Isaac Newton in October.
Fantastic. And aren't you organising the second Essex Astronomy Day as well?
Indeed. Last year, I was always thinking, well, there's quite a few clubs in Essex. There's about 7 or 8 of us. And I thought, well, why don't we get together? So I proposed it to all the heads, if you like, of all the other groups. And we decided, well, let's go for it. And we organised it, and we had speakers from each of the each of the groups, so we didn't have to pay anybody effectively, which is quite nice.
Nice.
Half an hour talk each, 10 minutes of questions and answers at the end, and it was really good. Hands in the air at the end if anyone wanted to do it again, and then it was unanimous that we gave it another go. So at the moment, we're just in the process of sorting out the speakers. We've actually booked Nick Simonik to come and give us a talk because he's only down the road from us in Colchester.
Right.
So he's going to be talking about robotic imaging.
Fantastic.
Well,
where are you going to hold the event?
Oh, we hold that in Burnham. We've got access to a nice, largish village hall. That did the trick last time. We can squeeze a few more people in. We just got to remember the bin bags to shut the light out because there's no blinds on the windows.
Right. Okay. Well, the very best of luck with that. Just out of interest, are Loughton Astronomical Society still going?
They are indeed, and they're coming along to us. Yes.
Oh, good. Because I was in a few astronomy quizzes against them, and I was with South East Essex Astronomy Society, and they had a fantastic way of winning every time because the quiz was always held at their base in Loughton. And you'd go over there and they'd take you immediately to the bar and get you so drunk you couldn't remember what your name was, let alone anything else. And it worked every time. But they were a formidable team. It's good to know they're still going anyway.
Yeah, they're still there.
Right.
But, Jack from Loughton giving us a talk at the Essex meeting all about spectroscopy.
Oh, nice. Fantastic. All right. So anyway, John's with us now, and I hope you viewers will make him very welcome. And I'm sure that we're going to have great fun with John, and hope he enjoys himself as well, obviously. So there we are. And Ian says, "Welcome, John. We're a friendly bunch. Usually. Yeah.
Indeed.
That caveat is important, actually, coming from Ian. So, you'll find out why. So there we are. Yeah, you are very welcome, John, and we're very happy to have you here.
Yeah, welcome.
All right then. So over to Roger, I guess, for the
Hey. After a gap from last week.
Yes, indeed. Yes. As you may remember, if you were here last week, viewers, Roger had severe technical problems last week, but he's back with a vengeance now, and just chomping at the bit he is to get into his role as the man who knows everything about what's going on in the night sky. So, Roger, take it away.
Okay, so here we go for coming up to the end of July already. So there we go. So we're heading towards the last quarter over the weekend for the moon. And this is the sun today in white light and in calcium K. I've recently been loaned a calcium K filter from a friend of mine, and he's not had much use of it. So he thought, as I got so many clear skies down in Sparkford, I thought it might get some better use. So I've been putting it to use in the week or so that I've been trying it out, and as you can see, it certainly produces a different viewpoint of the surface, and it seems to show all the faculae up all around the sunspot areas and things. So one way of getting a different viewpoint on from that part of the spectrum.
Fantastic.
Of course, being in the blue UV end of the spectrum, it's not very useful for visual because the eye is very weak at that part of the spectrum, so it needs to be done with a camera. So there we go. But I'm loving it. I don't know whether he might get it back. So this was just after the full moon, which was a full buck moon, as one of the American tribes likes to call it, and not too bad at all. But during the upcoming week, this is all based at midnight, you'll notice that the moon is gradually rising from its very low altitude, but also following on, we have got Saturn. And that is a very welcome news to see something in the night sky.
Indeed.
Of course, we've still got the dominating summer triangle of Vega and Altair and Deneb, so that's quite good. And we've also got Pegasus and the Andromeda Galaxy starting to get to a favourable height in the sky. So that's all well and good. We've still got the core of the Milky Way all through the night, and as of last Thursday from my location, we're starting to get astronomical darkness. It will be, so it'll probably be by the end of the week about 2 hours of astronomical darkness. So that's all well and good.
Good.
But during the 4 o'clock hours in the morning, which I'm showing here, you should get a nice view of Mars and Jupiter.
Oh, right.
Although we have got Uranus there, but that will be a bit more of a target, being so much smaller and fainter against the rising sun in the morning a bit later on. But it should be quite good, and all well and good there. So let's just move that on. So now we have at 4:35 tomorrow morning a double shadow transit across Jupiter, and that is Io and Europa will be shadow transiting across the surface. So if anyone is feeling a bit wide awake at that time of the morning, then a fab opportunity to see 2 shadows going across. So,
is that BST, that timing?
That is at 4:35 BST, 25 to 5 in the morning. So
Right.
it won't be too. It will be up above the horizon, but it shouldn't be too much of a challenge, providing you've got a good enough horizon from where you might be to see it. So just be aware of that at 4:35 tomorrow morning.
Right, lovely.
But in the evening, we've got Venus and Mercury fairly close to the sun at the moment. So Venus is still bright enough to be able to see it quite well, and Mercury probably a bit more of a challenge, but obviously be very careful. But a pair of binoculars should get you to spot it, but obviously it is still quite a low down in the sky. But an opportunity to see Mercury if you've never seen it before. Comet Obers, that's still traversing through the bottom part of Ursa Major, even though it's still reasonably bright at that time of the day. And it's unfortunately starting to fade away now, from 6.8 to 8.1 by the middle of August.
Fading fast.
So it's fading fast. But we've still got Shinneson Atlas, which is still heading towards us and gradually increasing in brightness. The tail's getting bigger, so things are still looking hopeful for the autumn. And as you can see, from 8.3 down to 6.9 by the middle of August. So by September, it's going to be naked eye visibility.
Fantastic.
Unless it starts to rapidly brighten up completely, but we shall see. We have a few images from the James Webb Space Telescope. This would have been on last week, but I wasn't here, unfortunately.
Oh, the penguin and the egg.
Oh, yeah.
The penguin and the egg. And it certainly looks like the description that they've named it after.
Yeah.
Yes,
I think it looks like a starling.
Is it? Okay.
Well, that's me being pedantic anyway.
Yeah. So some information there. 326 million light years away, and it's the image is 210,000 light years across. So it's not a small one. But then you can see dozens and dozens and dozens of galaxies all around it wherever you look in the image as well, as you would expect.
Yeah.
So it's
that is a big amount of disruption, isn't it, to those galaxies?
absolutely, it's huge. That must look amazing from one of those nearby galaxies.
Yeah, can you imagine? Gosh.
So we've got some more information from Exoplanet WASP 39b with some more information on its constituent parts of the atmosphere. And as you can see, when it transits across, it drops 2.5% the brightness of the star, which is a hell of a lot, isn't it?
It is.
It's not usually anywhere near that. So
it's usually around 1%. So this,
if that.
Yeah. So this is either a very large planet closer into the star, or a smaller one much further out.
Yeah. And also the atmosphere. If you look at the shoulders, they're very sharp. So the atmosphere is very tenuous. It's very thin.
Yeah.
So because usually if you get a nice thick atmosphere, you get a sort of like a nice round curve on the shoulders. Yeah.
Yeah.
So, interesting.
Very interesting.
Yeah. Anyway, so on to the exciting part, the Space Oddities gallery.
Hey.
So the first one we've got is from Graham Turvey, who's been putting a Bader film solar filter on his sea star, and he seems to think that the information he gets with that filter is better than what he gets from the sea star itself. So there is a lot of details there.
Yeah, there's a lot of detail.
Yeah, he's picked up lots of tiny little.
The umbra around the actual spots is amazing, isn't it?
I didn't know a Bader film filter was sold for the sea star.
Well, you probably just probably 3D print a holder and just put the Bader film into it.
No, they're supplied with one. They're supplied with a solar filter.
Yeah, but I don't know whether it's a Bader one or not. So this might be an additional.
I don't think it is.
Additional one to it. So anyway,
that's nice.
Right, we've got Saturn from Kevin Earp, taken over 3 years to show how the edge of the rings gradually narrow down.
Oh, lovely one.
Wow.
Yeah. Yeah, he says that the earlier one's not quite as clear. So he's hoping that it's his processing over the years that have improved his images. And they certainly
I'll give him the benefit of the doubt. Yeah. Well, yeah, you're improving.
They're all very good.
Yeah,
he's
very
doing
good.
well.
Well done, Kevin.
Okay. Right. Now here's one. This was one that I got published in the August edition of Astronomy Now magazine.
Well done.
So I was quite pleased with that. So fortunate, I put the same 3 images to Sky at Night magazine and to Astronomy Now. Yeah. Fortunately, both magazines have picked different images, so that's fortunate for me. So so this is a very good image. I was really pleased with using that. And if you notice the craters towards just below the center, you can see a dark line, and that I think is a collapsed lava tube.
Yeah.
Yeah, run into the edge.
I was going to ask you what that was.
But I'm assuming by the scale of the crater that lava tube must be quite a way size, quite a decent size across. So I don't think you'd be able to jump across that.
I'm going to look further into that to see what the hell it is.
Okay, so it's another one of mine, but I've been enjoying getting some calcium pictures of the sun. But I've managed to have a chat with the person who loaned it to me. He says you can get the prominences with it. So using IMPPG, which is what I usually do for solar and lunar imaging, adjust the curves, and as you can see, there is a bit of activity around the edge there.
Got it.
So I was quite pleased with that. And Kevin says it's Petavius, the crater there.
Right. Oh, look into that.
So there we go. Right, and one more of the sun in calcium, and I've sort of processed it slightly different there. But it's It's proving quite interesting getting all the faculae detail all over the surface there, which surround a lot of the activities that we can currently see. So
That's nice
it's
contrast, Roger. That's
yeah. So I think that's a better way to go rather than just using a white light filter where you can just see some of the details on the surface. This is brings it out to the nth degree with all that detail there. So
Yeah.
I don't know how much longer I can borrow this filter. Anyway, Graham has put a sea star picture taken from Bedfordshire on the 17th of July. Conditions were far from ideal with some high cloud, and it was low in an orange tinted sky. So he liked it. No processing, and just cropped with some software on his iPad. That's what we've got.
That's lovely.
Yeah.
Wow.
Got some good details there.
Yeah.
Very impressive.
Very nice.
Very nice.
Yeah.
Very
So,
nice. Indeed. Well done.
That's an ejecta
Right.
in there.
Oh,
Yeah.
Oh, and one from Michael, which is also a
Who the hell let him now?
a moonshot. But this was done with a Lumix bridge camera at 1200 millimeters.
A late contender.
A late contender. And
Oh,
yeah,
Okay.
not bad for a bridge
Yeah.
camera.
not bad. No,
no.
absolutely not. I've
They're
got,
all right
I've got a Lumix up there. I might try a similar sort of thing.
Yeah.
Yeah.
Okay.
Thank you, Roger.
Well, that's all right. And now we've got Jerry DeLay, and he's got the Dumbbell Nebula, which was done with a 6-inch Ritchie Critchie on, and 12 5-minute. So it's only an hour. Gosh, wait till you see the result. Look at that. That is
Wow.
awesome.
That's amazing.
That's 1 hour.
So bright.
Amazing. Very
Wow.
good.
Incredible.
I think that's one of his bestest ever,
I would agree.
in my opinion.
Yeah, no, I think that's superb.
That's very good.
Elements on that, yeah.
Very nice. Yeah, you got sort of the details going into the center there of the red elements of gas there. Wonderful. Very good. So
Indeed.
that concludes the gallery for this week.
Oh, yeah.
Excellent.
Excellent.
There we are then. So,
Amazing.
thank you for that, as always, Roger.
Thank you.
We will.
Can I just add to that, just to the diary? We have actually started, it's very early days, but we have actually started Perseid's season.
Oh yes.
Of course, the meteor shower. It's actually started. They some meteors have been seen. So they're beginning to pick up. The actual peak is at the 12th and the 13th. So up until then, it's now's the sort of like time to start looking, because we're coming down towards the new moon. So we'll be getting dark, and there's more chance that you're actually going to see something. But around the 12th and the 13th, we're coming up to, or we're around the first quarter moon. So hopefully, as long as it doesn't get too much in the way, we should still be able to see something at the peak. But of course, it goes on after that. I think it's to the 24th of August. So there's always a chance you'll pick up some meteors, 100 comets an hour. That'd be good, wouldn't it? 100 meteors, or that's the. Of course, you won't see 100, but and always remember, you don't look at where they actually are coming from. Look to the side, usually about 45 degrees either side. And then, because if you're looking at it, they're coming directly towards you, and you're lucky if you just see a flash. But if you look to 45 degrees either side, or even a little bit further, you will see the long ones, because they are traveling away from you, and then you'll see the actual streak. So yeah, good Perseids watching. Let's hope
Do we know what the moon's doing this year for the peak night?
It's gone. It's gone. It dips out early in the evening. So
Oh,
by the time
so hopefully
10 o'clock comes, it's out the way.
Oh, fantastic.
Yeah. Of
Oh,
course,
thanks,
and,
guys.
so yeah, this
So
is going
yeah,
to be
don't
good.
forget, viewers, the peak night of the Perseids is the 12th, 13th of August, that's when you should go outside. You can see them from now until really the end of August, really.
Yeah,
But the
exactly.
peak night
24th, I think they're saying.
is the 12th and 13th. That's the most spectacular night.
Mm.
Get away from any lights, obviously. Get as dark space as possible. Lean on lay on a sun lounger, just lay back and relax, and don't bother about trying to take any photos or anything. Just enjoy the spectacle.
Just enjoy them, enjoy them. If
Mm.
you are going to take photos, put it on repeat and just let it click away. If you get them, you get them. If you don't, you don't. Because of course the sky's a big canvas, so you're going to have to really cover quite a lot of area. So unless you've got 2 or 3 cameras, but just put them on repeat and just let them click away. But remember, the next day you've got to go through all those images. And I think the last time I did it, I had about 1,000 images off about 4 cameras just to sort of cover things, and I think I got about 5.
Yeah.
It wasn't the best seeing. But
and you can have some really good years. I remember one year I was at Astro Camp that used to take place in the Ashdown Forest in Sussex. I used to go to that every year in August. And at the peak Perseus night one year, between sunset and sunrise, we counted 625 meteors. So
sweet.
You can have some really good nights.
My astronomy club runs an annual Meteor watch, and so we're all geared up for that. The first year we did it, there was the first meteor we saw after the sun went away. It was so bright, it actually cast a shadow.
Oh, lovely!
Absolutely amazing. Went from horizon to horizon almost.
Fantastic.
Yeah, that's good. Of course, we've got to mention that the parent of all these meteors is the comet Swift-Tuttle.
Yes,
so,
that's it.
I don't know if I've got a number. Let's have a look. See,
Alan Ledbury says Perseids I like to look straight up. They're closer and brighter.
Yeah, it's 109p Swift-Tuttle.
Yep, that's right.
109p. So
and just a word of warning, viewers, for safety: never look at DAS with the naked eye. So I just sort of mentioned.
Always use filters.
Always use filters. Absolutely.
If you hear me shout full moon, don't look.
Okay, all right then. So just a request. Do remember to like and subscribe, because it really does help us get noticed by the YouTube algorithm. And the way that YouTube works, the whole ambition, the whole aim of the YouTube algorithm is to show the right video to the right person at the right time. That's all it's trying to do. It's not bothering about anything else. But how does it know what the right video is? Because it sees how many likes and comments these videos get. So if you could like the video after it's been posted on the channel, that would be fantastic. Unfortunately, likes or anything really within the live chat don't count. So if you could just remember, after the video has been posted on the channel, just give it a quick like if you could. And for anybody out there watching who isn't subscribed, they would be very appreciative if you could do that, because again, it helps us with the algorithm, helps us get noticed, which is of course what we want. Okay, what we're going to do now is to move on to today's news. There's quite a bit of news to get through today. There's a lot been happening over the last week or so. So let's delve into this week's news. Just give me 1 second to set myself up here. And it's just right. Okay. So I hope everybody can see that. Here's the news for the 23rd of July. The first big story is that NASA's Viper moon rover has been cancelled. The Viper stands for the Volatiles Investigating Polar Exploration Rover, and it was due to launch to the moon later this year in a quest to drill into the lunar surface at the moon's south pole in search of the ice, which several orbiting spacecraft have indicated does exist below the surface of the lunar south pole in large quantities, and therefore could be an invaluable source of water for future lunar bases at the south pole. The rover was to launch to the moon atop a SpaceX Falcon Heavy and to be delivered by the surface by Astrobotics Griffin lander. The problem is, you see, the project has suffered from delays and a 30% cost overrun, up from a budgeted $400 million to $630 million. This overruns resulted in half a dozen smaller experiments being denied because monies had to be diverted to Viper to pay for the overruns. And this is coupled, of course, with a $1 billion shortfall in the planetary science budget that Congress has awarded NASA. So all of these factors together have meant that NASA's now completely cancelled the rover, which is a great shame. I'm sure Lou will have something to say about that in a while. It's hoped that Viper's technologies can be repurposed for future missions, but as it stands, Viper is dead. It is no more. It is an ex-rover. So there we are. Moving on, Gaia, the European Space Agency's Gaia Observatory, which is producing the most detailed maps ever of stars in our Milky Way galaxy, has survived 2 incidents which could have brought its mission to an end. The spacecraft was recently slammed by a micrometeoroid and struck by a solar storm, leaving it unable to function properly. But it's now back in business, back to routine operations, and it's okay. Gaia orbits at more than 932,000 miles, or 1.5 million kilometers from Earth, at what is known as the L2 Lagrange point, where the combined gravitational forces of our planet and the Sun create a stable orbit. The spacecraft's goal is to create a 3D map of individual stars in the Milky Way. But what happened in April, a meteoroid smaller than a grain of sand hit Gaia and damaged the protective shield surrounding its instrumentation. In the months since, sunlight streaming through that tiny hole has disrupted the spacecraft's sensors, according to the European Space Agency. In May, for unknown reasons, another piece of electronics failed, part of the system that enables Gaia to validate its detection of stars, resulting in thousands of false detections. This might have been caused by the same burst of solar particles from the sun that triggered all those wonderful aurorae that we had around the globe in May. There's little the Gaia team can do about the spacecraft's hardware, but they were able to patch its software to keep the spacecraft going, altering the threshold at which Gaia classifies an object as a star. The spacecraft was launched in 2013 and was expected to last for 6 years, but it's still going. It's continuing to produce the most accurate 3D maps of stars in our galaxy, cataloguing the exact position, brightness, and spectral type of, so far, 1.5 billion stars. It's opened a completely new window on the Milky Way and has made many interesting discoveries. For example, many previously unknown star streams and clusters. Gaia's also discovered that about 10 billion years ago, our galaxy underwent a merger with another galaxy, which was not previously known. And it's also discovered more than 380 gravitationally lensed quasars, and have closer to home in the solar system. It's matched the precise position and orbits of more than 150,000 asteroids. But it's Gaia's unprecedented precision in what it's measuring that is a real game changer in the study of the Milky Way galaxy. So it's good to see that it's back again producing data. Now, big surprise for Mars. The Curiosity rover has driven over a rock on Mars and split it open, and what was inside, pure yellow sulfur crystals. Now, since October 23, the rover has been exploring a region of Mars where the soil is rich with sulfates, which is a kind of salt that contains sulfur and forms as water evaporates. But where past detections have been of sulfur-based minerals, in other words, a mix of sulfur and other materials, the rock Curiosity recently cracked open is made of pure sulfur. Now, sulfur only forms in a narrow range of conditions that scientists haven't associated with the history of the location where Curiosity is. And Curiosity's found a lot of sulfur, an entire field of bright rocks that look just the same as the one it cracked open. There's currently no explanation of how the sulfur got there. We normally associate sulfur, obviously, with volcanic activity, but in this case, there are no observations to support the idea of volcanism at that location. So, obviously, planetary scientists are scratching their heads a bit at what that accidental discovery of sulfur means. So, that's quite an interesting discovery. You may have heard of the asteroid Apophis. It's classed as one of the most dangerous asteroids in the solar system. In 2029, it's going to make a close approach to the Earth. And this NASA Caltech graphic shows the trajectory of the asteroid in 2029. And the things whizzing around the Earth are orbiting satellites. Now, what you can see from this is that Apophis will pass inside the orbit of geostationary satellites, which are usually about 24,000 miles out from the Earth. Apophis is going to approach the Earth to within 20,000 miles, so closer than the geostationary satellites. It's long been speculated in some sort of panic frenzy, largely whipped up by the popular press, that Apophis could actually strike the Earth in 2029, but that's not going to happen. And we now know that its orbit will take it, as I said, 20,000 miles away from the Earth. Astronomically, that's a close call, of course, but it doesn't pose any danger to the Earth. It's going to pass so close, in fact, that we should be able to see it sailing through the night sky. So look forward to that. It's due to pass close to the Earth again in 2036, but again, there's no danger that it's going to actually strike the Earth, according to the latest information. What the European Space Agency has decided to do is to send a new spaceship called Ramses to fly to Apophis in 2029 to observe it. And Ramses is short for Rapid Apophis Mission for Space Safety. Bit of obviously a contrived acronym again there, never mind. And as its name suggests, it's the next phase in humanity's efforts to learn more about near-Earth asteroids, or NEOs, and how we might deflect them should one ever threaten the Earth. In order to launch in time to rendezvous with Apophis in February 2029, scientists at the ESA have been given permission to start planning Ramses even before the Space Agency has officially adopted the mission. The sanctioning and appropriation of funding for the Ramses mission will hopefully take place at ESA's Ministerial Council meeting, involving representatives from each of the member states of the European Space Agency in November next year, 2025. To arrive at Apophis in February 2029, launch would have to happen in April 2028. So let's hope that funding gets passed and we do get a spaceship or spacecraft going out to Apophis to observe it at close quarters.
Andy, is that the one where Apophis Rex is going?
Osiris Rex?
Osiris Rex, yes.
Osiris Rex, sorry, yeah.
Yes.
It's been renamed, hasn't it, to
That's right.
Apophis Rex. So that's rendezvousing as well. So
yeah, that's right. So it'd be nice to have a European spacecraft.
Yeah, exactly.
As well.
Yeah,
and hopefully they can do some sort of joint observation program.
Yeah, it'd be nice.
Yeah, it'd be fantastic. Talking of asteroids, last month an asteroid bigger than the Great Pyramid of Giza. That seems to be quite a fashionable size to compare asteroids with recently. The Great Pyramid of Giza hurtled between Earth and the Moon at more than 21,000 miles an hour, or 34,000 kilometers an hour. And astronomers managed to get the first ever pictures of this space rock. These are they. And what happened with this asteroid is that the Earth's gravity knocked it off course and forever changed its journey around the sun. This asteroid is named 2024 MK, roughly 500 feet or 150 meters across. Obviously, it's a city killer type asteroid, and it is potentially hazardous, obviously, and it was first spotted on June the 16th. So quite a late spot there. And it was discovered by the NASA-funded Asteroid Terrestrial Impact Last Alert System, or ATLAS, lovely, in South Africa. On June the 29th, just 13 days after it was discovered, 2024 MK reached its closest approach to the Earth, and it skimmed our planet's orbit of a distance of around 184,000 miles, so about 3/4 of the way to the Moon. So the Earth's gravity has actually affected this asteroid's orbit, and let's hope it's affected it for the better so that it doesn't come any closer to the Earth next time. But there we are. So that was quite interesting. A rare type of black hole has been found. Now, the Hubble Space Telescope has recently peered inside the Omega cluster. It's a densely packed cloud of stars some 17,000 light years away, and made quite an interesting discovery. It's found a so-called intermediate mass black hole. That is to say, a black hole in the mass region between stellar mass black holes, which are formed from collapsing stars, and supermassive black holes. Stellar mass black holes have masses up to 100 times that of the Sun, and supermassive black holes is the term given to those possessing upwards of 100,000 solar masses. So in between, astronomers have found very few black holes, and the question's always been if those black holes actually exist or whether we just haven't found them. It's not logical to astronomers, and certainly not to me, that there are no black holes between 100 solar masses and 100,000 solar masses. The only previous detection of one through gravitational waves showed a black hole with 142 solar masses towards the bottom end of that mass range. But astronomers were desperately looking for another example to confirm that these intermediate mass black holes actually exist. Now, because the Hubble telescope's been imaging the Omega cluster for more than 2 decades, they've got a lot of data about the stars in it, and astronomers were able to precisely measure the motions of more than 1.5 million stars in the cluster. They found 7 stars right at the center of the cluster, which are moving extremely fast. So fast, in fact, that they should be thrown out of the cluster. Something is preventing their expulsion, and it turns out they're being held in orbit around a black hole between 8,000 and 50,000 times the mass of the Sun. That can't really be more precise at the moment. It can't have any more than 50,000 solar masses, because if it did, we would see many more stars affected by its gravity. And it's only the second time we've seen individual stars in orbit around a black hole. The first, of course, being those orbiting the black hole at the center of our galaxy in that wonderful image of Sagittarius A star taken by the Event Horizon telescope, and many decades work from astronomers mapping those stars orbiting the black hole at the center of our galaxy. Nobody actually knows how a solar mass, an 8,000 upward solar mass black hole gets created. One possibility is that small black holes might merge together into a larger one. Another possible way to grow intermediate mass black holes, recently suggested, is that many stars might collide in a dense cluster like the Omega cluster in Omega Centauri and become a very single massive star. And later that big star would collapse directly into a black hole. Understanding where these intermediate mass black holes are and how they grow may help scientists understand what role they could play in the evolution of black holes and galaxies. And of course, this research into the relationship between the growth of black holes and the galaxies they sit in is a hot area of research these days, because there's a lot we still don't know. So there we are, rare type of black hole found. And now it's let's have a look at just briefly at some spaceflight news for this week. Boeing Starliner, what a surprise, still stuck in orbit. The mission to the International Space Station, taking 2 astronauts there, launched to the ISS on June the 5th. And as we know, ever since, the Starliners have massive problems. This is a test flight, if you like, for the Starliner, the first to take human crew to the ISS, and it's been a bit of a disaster. Problems with the thrusters, helium leaks, still ongoing problems. NASA have said that they hope that they will bring the Starliner home around mid-August or possibly a bit before, when they've analysed all the data from the tests they've been doing on the ground of how the thrusters behave. They found that the thrusters, for some reason, are overheating and becoming less efficient, and therefore delivering less thrust, but they have no idea what's causing that, and Boeing don't either. It's a bit of a disaster for Boeing. We've often talked about the disaster of the Starliner capsule, and the latest rumours circulating say that Boeing is actually going to cancel it altogether very soon because it's costing them a lot of money, and they've got a fixed price contract from NASA. And for every year that they don't manage to get the Starliner into service, it's costing them $1 billion a year. And Boeing actually want to concentrate on their aviation division at the moment, which, as you probably know, is come under a lot of fire after that cabin door blew out, and the two crashes with hundreds of people died. So Boeing are in crisis generally, and the consensus is they want to get rid of the Starliner so that they don't have that to worry about on top of everything else. So there we are.
Just a quick comment about fixed price contracts from NASA. Companies who bid these are in kind of between a rock and a hard place. On the one hand, they want to come in at low price, right?
Yeah.
On the other hand, a fixed price contract transfers all of the risk to the developer. Right?
Yes.
NASA has no risk. They say, here's your money, make it so. So when fixed price contracts are bid, they tend to be bid with much higher overheads to account for the risk. And the question is, how much overhead did they account for?
Yeah.
So we don't know if they're losing money on this yet or not. But
oh yeah, they've already lost. It was over.
Oh yeah, they've lost billions on this already.
Yeah, because but also it's actually got contracts for some flights, but with all the delays, and with the International Space Station being decommissioned and things like that, they're saying that by the time it starts to come into full production, then it's going to have nowhere to go, which is another problem that they're looking at with this. But Boeing have also said now that they will never do a fixed price contract ever again. And the unfortunate thing is with the fixed price contracts, is the private sector are using fixed price contracts and they're achieving it. And this is where, of course, it makes it look twice as bad. I mean, my opinions on fixed price contracts and things like that, and how certain companies work. But I think this was one thing where basically their chickens came home to roost. Because I mean, they got, I think if I remember right, they got virtually twice as much to do the Starliner than SpaceX did.
They got 6 billion, I think, from NASA, and I think SpaceX only got 2.5.
Yeah, they got more. So it's. I mean, they can make all the excuses they want. I mean, these are the people who have been building rockets from the year dot, so they should know how to do this now. And it's a case of that they've always seemed to have an excuse of why things are overrunning. And sometimes they say, well, the plans that they're given from NASA are not mature and things change as they go along. Then they have problems with. I mean, these are the guys that have got all the toolings, and they're all on their sites.
Yeah. Well, that is a good point, Daz. That is a good point. I haven't worked on fixed price contracts, but in the support services realm, we've worked in contracts where you set a requirement. It's a hard requirement. You're not allowed to really talk to the government. All they get to do is see your performance based on schedule and cost. However, the real world is that changes come about over a period of years. Things change. And so at that point, you have to start thinking about whether you're going to try to renegotiate cost. And I don't know what the issues are with this particular piece of equipment, but it's not like buying a printer. I'll say it that way.
No, I agree. We're spacing hard. We all know that, yeah.
I mean, a color printer maybe, but not the black and white ones.
You see, you've got the two extremes, haven't you? You've got the fixed price contracts where all the risks are taken on by the developer, and then you've got the hours plus contracts where all is taken by the taxpayer, basically.
Right.
So I don't think either is an ideal solution. Anyway, thank you for those thoughts. Moving on. Falcon 9, SpaceX's Falcon 9 is expected to return to flight on Thursday after it was grounded by the FAA, the Federal Aviation Authority. And they grounded the Falcon 9 after a flight carrying Starlink satellites to put into orbit had an oxygen leak. And it was fatal to the mission because although the satellites were deployed, the Falcon was not in high enough orbit, and the satellites just came straight back into the atmosphere and burned up, unfortunately. So SpaceX lost 20 Starlink satellites, which some here might think is a good thing. But anyway, let's not get into that now. It was the first Falcon 9 failure since 2017, and in that time, it's flown 364 missions without any problems at all, making it the most reliable rocket ever built. And if the FAA does grant a license for launch on Thursday, as SpaceX planned to launch, it means they've identified what the problem was and they've come up with a resolution. And SpaceX can therefore get back on their launch schedule for this year, because this year they aim to launch 150 times of various rockets this year. So they're aiming for 150 launches this year. And it also means, hopefully, that the highly anticipated Polaris Dawn mission can go ahead on schedule. We'll be talking about Polaris Dawn a bit more as soon as we get a launch date, because that's such an interesting mission. Now, staying with SpaceX, they have been contracted by NASA to kill the International Space Station when it reaches the end of its life in around 2030. And this contract is worth $843 million. And they will be developing a version of the Dragon spacecraft, which will attach itself to the International Space Station and with its thrusters push it out of orbit into the atmosphere, where most of it will burn up, and what doesn't burn up will go straight into the Indian Ocean. It's not a universally popular decision. Many people are protesting that instead the ISS should be boosted to a higher orbit and left as a monument for future generations, because it is an extremely potent symbol of international cooperation. There were 27 nations involved in the International Space Station. So it seems a real shame to destroy it, as it's such a potent symbol of cooperation. SpaceX have also been awarded a $267 million contract for rescuing astronauts in orbit from danger in whatever scenario where rescue is needed, a sort of a Thunderbird 3 approach to spaceflight, if you like. It's thought that this would involve using the Dragon spacecraft as a sort of a space lifeboat to rescue astronauts in peril. And I think it's really admirable that NASA have had the foresight to plan ahead for such eventualities, as space is being opened up more and more to private companies, and many more launches are going to take place each year over the coming decade. Such a contingency plans never existed before. But it's not known if SpaceX would rescue astronauts from other countries if they were in danger, for example, China. That's actually not clear at the moment. I'd be very surprised if they did. But I guess China would have to request them. They'd have to ring John Tracy and ask for help. So that'd be interesting to see. But at least NASA are thinking of the future and the fact there are going to be more manned launches inevitably over the next decade. So if any of them do get into trouble, then SpaceX have got the contract to rescue them. Which is
this is an interesting story, because at the end of the day, I'm assuming that you'd virtually have to have a Falcon 9 with this capsule sat on the top, virtually ready to go
on
at all
standby.
times. Yeah. Which would make an interesting scenario, because, like you say, these things do degrade. So how long would you have to? Because you have to change batteries out. You have to keep it. I mean, fueling's no problem because it doesn't take that long to fuel them.
No.
But you literally have to have one on standby. It's an interesting scenario. It'd be interesting to see what they come up. But also, when you think they return this International Space Station, do you think they'll take the solar panels off and separately, because it's a massive chunk, isn't it?
I don't know. Sorry, John, were you trying to say something?
No.
It was me.
It's you.
Sorry, the SpaceX killing the ISS with the rescue mission for SpaceX reminds me of the film Marooned.
Yes, absolutely. I was about to say with Gregory Peck.
Yeah. That's the one.
I saw that.
Sorry.
I saw that when it was in the cinema, believe it or not.
Oh, right.
Yeah, because the nearest we had to it was when there was 2 shuttles on the launch pad,
Yeah.
Just after the Columbia disaster.
Yeah.
That was the nearest we got, but that second shuttle wasn't there specifically for a rescue mission. It was basically it was being prepared for a later mission, but they were thinking, well, we could use it if we need to. So yeah, it's I'd be interested to see where this goes.
Yeah, absolutely. Okay, so last item today, the successful static fire of the Falcon Super Heavy B12 booster. Here we go. So this looks like it was a complete success, and we're just waiting for the fifth orbital launch, of course, which should be happening maybe around the first week of August, latest estimates. Now, this launch will be different, or at least the landing will be different, because they're going to try and catch the Super Heavy booster as it returns to the Boca Chica launch site in Texas. It's going to fly down, position itself beside the launch tower and hover, and then those giant mechanical arms called, or nicknamed, the chopsticks are going to get hold of it. And then it will turn its engines off, and the chopsticks will lower it back onto the launch mount, ready for refueling for another flight. And Ryan Hansen Space have produced this lovely animation of what that might look like. And, you know, this is the nearest to Thunderbirds you'll ever see in your life.
Yeah.
It sounds crazy, because that booster has to position itself next to the launch tower in exactly the right place to a tolerance of a couple of centimeters if this method is going to work. This method is being used to save them having to put landing legs on the booster, which of course add to the mass and make it a lot heavier. So this is what we could see happening in August with the orbital test flight. See, it has to position itself so accurately on those pins, and then the engine's cut off, and then after that, the chopstick arms slide down the tower and position the booster back on the orbital launch mount. I mean, it's crazy, but you know, this is SpaceX. They're always pushing the boundaries of what is possible. The potential for disaster, on the other hand, if it goes wrong, if it slams into the tower and wrecks it, well, you know, but they've got to try it sooner or later. So
I think that's why they're rattling on with the building of the second tower, just in case.
Yeah, they are building a second tower beside it, which is coming on phenomenally fast. I see they've got 3 sections up now. They only had 1 last time I looked. You know, we can't wait to see this, because I mean, you know, as I said, you can't get much more Thunderbirds than that. So we hope you would join us for live coverage of the 5th orbital attempt to get the Starship and the booster into orbit, and then the booster back and caught like this with the catch tower, with Mechazilla, as it's called, with the chopstick arms. The Starship will probably splash down in the ocean again like it did on the last test flight, but we can't wait to see this being tried. Either way, as Elon Musk always says, excitement is guaranteed. So there you are. That's it for the news this week. I'd like to just ask Lou, are you really disappointed about Viper?
I'm not all that disappointed. I understand cost overruns and all that, although apparently that was not the case with James Webb. So the decision had to be made, and yes, the planetary budget has been cut, and Mars sample return is either dead or on life support. So I get that. However, they will scavenge the Viper instruments for use in other lunar missions. So that's a good thing. And I remember some years ago, there was a program called RLEP, the Robotic Lunar Exploration Program. And its goal was to send 4 robots to the moon, most of them orbiters, I think, to scout it out for landing sites and material and minerals and so forth. And only one of them got built, and that's LRO, Lunar Reconnaissance Orbiter. The other 3 were canceled. It does seem a little backwards to cancel robotic missions, which have the biggest bang for your buck when you're talking about science return, versus human missions. But some of its political climate and other things that are above my pay grade. So anyhow, the instruments will get reused in other lunar missions. And,
so it's not a total loss.
It'll be okay.
I mean, there is even talk of possibly, if somebody's interested, of actually taking the whole robot on and sending it up themselves. If they're into, there is talk around that could happen. And like you said, either that or it's going to be cannibalized in other parts, used elsewhere. The only thing is, like you said, yes, it is because it's overrun by over 30%. But the thing is, it's so close. It is really. They've even paid for the launch, and what they all it needed was to go into the condition, the environment chamber, to be tested. Well, that's going to cost money, but at the end of the day, it's probably going to be, it probably would have been better to do that and then send it up because everything's paid for. Because now all they're going to do is they're just going to dump a mass decoy, not decoy, just put a mass on this machine there because something's got to be sent when that rocket launches because it's still going. Because Astrobotics is going. Mass simulator. That's it. Sorry.
Move your time frame a little forward, and this is the decision that has to be made every time there's a request for an extended mission. In other words, you have a mission that has been developed and launched and returned data, and its planned lifetime is ended. Then the instrument teams, the mission teams, have to submit a proposal for, hey, we've already spent this money. There are some new science objectives we can accomplish. Give us more money, extend the mission. And many times they are, and sometimes they aren't.
Yeah, absolutely.
Well, it's a sad state of affairs, but like I said, it was just so close. So
far. Yeah, John, do you have thoughts about that?
Well, it'd be nice if they could keep the thing going and actually use it for what it was designed for, because they're going to the moon, to the South Pole on manned missions to actually try and find ice, which is what this thing's designed for. And if they can narrow down some target areas before we actually get there, it'd be a useful set of information to make the manned missions more efficient.
Yeah, absolutely.
Because these experiments have now got to be done. If Artemis gets there beforehand, they will have to be done by astronauts now, which is taken, like you say, interfering with the schedule that they had planned anyway. So it's a sad state of affairs. But so watch this space scenario. Maybe they might have a reprieve. You never know.
And and I must ask Lou, what do you make of this discovery of sulfur on Mars, Lou? That was a bit unexpected.
Yeah, it seems that this was may have been in some sort of an ancient riverbed with deposits in it. But we haven't discovered sulfur before, so that in itself tells us that the formation and evolution of Mars might be a little different than we thought it was. Otherwise, I don't know. I mean, it is a prevalent element in the interstellar medium, so not crazy that they would find it, but they found it in quite a large abundance. So I think we'll have to wait and see. Let the modeling people have their ways with it.
I think, could it be the product of volcanism?
Yes, could be, and we believe the moon was volcanic very early in its formation.
There was a question from Ian as regards when we were talking about the medium-sized black holes, and he was asking. He wonders if the midi black holes are unstable and leak their mass away very quickly. Now, I know that this theory about there possibly being black holes at the center of some of these bigger clusters has been around for years, and I know they've been using computers to model simulations of what could be going on, because they think they have sort of like detected possible mini black holes, like you were saying, and they were wondering whether or not they basically merged and formed a medium black hole or what. But for them to actually find one now, I mean, this has been going on because I remember reporting on this years ago, about how they've been using the modelling. But as I said, as regards Ian's question, any ideas, anyone, whether or not they could leak their mass away very quickly,
Well,
being unstable?
the work that Hawking did showed that Hawking radiation is more prevalent, so smaller black holes do evaporate quicker than large ones. So in theory, yes, the midi ones will evaporate quicker than the supermassive black holes, but not as quick as stellar mass black holes.
So the question is, did they form and go away, or are they unlikely to form? And I think Daz, you and Andy hit on it. You need a physical mechanism for this, and we know what the physical mechanism is for stellar mass black holes. It's stars. And there's a physical mechanism, although they don't understand the process and dependencies for galactic black holes. For intermediate sized black holes, we've been looking for them for a long time. Either haven't found them or they're very rare. And the mechanism is a little unclear. If you want to form one out of a globular cluster, for example, then you're trying to form a black hole out of some very, very long lifetime low mass stars, and that becomes problematic. So you need some kind of collection of mass that can stick around for a while, and I just don't know what the mechanism would be for that.
Yeah, because what they were sorry, John, carry on.
I was going to say, is it something similar to the two galaxy formation theories, the top down or the bottom up? So you might have a lot of stellar mass black holes converging into one, or is it a large accumulation of gas that forgoes the star formation and just collapses straight to a black hole? Because the black hole itself doesn't have to necessarily be a singularity to have sufficient mass to prevent light from escaping.
Good point, John. I just asked that question at the Alcon conference this past week. There's a woman giving a talk on some of her dissertation work about black holes and dark matter and all kinds of things related. And I just asked the question, which forms first? She didn't know. So,
I think
it's an open question.
Can anybody answer? This one is for Roger, I think. Somebody, Sea Lightning 300 MI says all spring astronomers said Venus would be visible before morning. It is still not being seen and now has been missing for months. Where is it? What have you done with Venus, Roger?
Empty your pockets.
Right. Well, if you saw the presentation I did earlier, you'll see it. It will be following the sun and will be visible for about an hour until after the sun has set. So have a look in the western skies to see it.
But it's definitely the evening star at the moment rather than the morning star.
Yes, yes, it's gone from the morning to the evening from last month. So keep an eye out for a twinkly star in the west.
Absolutely.
Very, very low down after sunset.
So we hope that answers your question. It's an evening object, not a morning. I don't know who said it would be a morning object, but it's definitely an evening object at the moment, and presumably as we go into the autumn, it will be a morning object again. So there we are. Okay, Ian, your point about the SpaceX rescue missions only being for obviously astronauts in Earth orbit, that wouldn't be, any use much further afield. So the contract is for astronauts in Earth orbit. So there we are. I hope that answers that. Patrick Moore, our favourite quote from the saintly Sir Patrick. We just don't know.
Just don't know. We just don't know.
Just don't know. So there we are. There we are. Okay, right. John, anything else in the news that took your fancy, so to speak?
Not that I can recall. I mentioned on the private chat that our erstwhile Comet Atlas was reported to potentially be breaking up, so we might not get the display we're expecting in the autumn, but fingers crossed that they were wrong.
Always happens, doesn't it? It's so typical. It's just unbelievable. I just,
Just when we get the promise of the bestest ever, something goes wrong.
Which was why, Hale Bob was such a surprise, because they promised us the best ever and we got it.
Yeah.
Unbelievable. But John, you're too young to remember this, but I remember Comet Kahootek in 1973.
I was around just, but I don't recall it.
No, I shouldn't you'd recall it. But it was going to take up a third of the night sky.
Yeah.
And we got really excited, and my dad and I went out, and it was a very tiny binocular object. And so disappointed I was. Not that I blame my dad, luckily. So so there we are. All right. Well, in case unless anybody's got anything else, I think we'll draw proceedings to a close for this evening. Would like to thank you.
You always forget my son thing.
Oh no, I haven't forgotten. I'm just teasing you.
Yeah.
I
wouldn't notice.
Just give me a second, because I now need to upload it.
It won't take long. Trust me, it won't take long. There is some interesting news, but
okay. Just give me a second. And hang on. I've just got to. Just give me 1 sec. Just talk amongst yourselves while I'm just setting.
It's been an interesting week. We've had it's been a record-breaking week, which I will talk about in a second. For cycle 25 and some past cycles as well. We started. The sun's been pretty quiet as regards CMEs and flares. They've been sort of tapering off, and this was making people wonder: have we gone past the peak of this cycle? But almost right from the get-go, from the 16th, which is last week, things suddenly picked up, and there have been things going on, but unfortunately nothing that rattled our cage on Earth, that gave us really nice auroras. But there have been a lot of action going on. As soon as we get it up, it won't take me long to go through it, because again, for some unknown reason, Helio Viewer just stopped liking me. They won't let me make.
That's weird. Is it still not working for you? Because it works fine.
No. I'll have a proper look at it tomorrow. Because you went on and it went straight away. It worked for you.
Yeah.
I can make basic films on Helio Viewer, just standard Helio Viewer, but I've got one ready in the presentation when we're ready, which I can put up. So, which was a week's thing, but of course as I said before, we've also had this thing where the Solic Dynamic Observatory is dipping behind the Earth, because it's an elliptical type orbit around the Earth. It disappears around the Earth for so many hours, and I think we're still working our way into the maximum of that. Then it will work its way back out again. So that interferes. Won't it load, Andy?
No, it's fine. I'm ready to go when you are.
Oh, okay then. Yeah. Whenever, mate, pop it up for me. It's only Christmas.
What happened to Lou?
Yeah, I thought that.
Okay. Well,
hopefully he can find his way back. He knows where we are. Yeah. There we are, Daz. Take it away.
Right. So so this is the space weather review for the last week, the 16th to I've done it again. That's the 23rd. That's twice I've done that. That's twice I've done that. That's the 23rd. Sorry, it's fat finger syndrome. I do apologise. And this picture here with the big CME in the sort of like 8 o'clock position was earlier this week. So it is actually, you can see it was on the 17th. So it was the day after we actually spoke. But before, if you move on, Andy, we'll just move to the next slide, please. Before we actually, while we were actually on air, there was also a biggish flare. There was an X 1.9 flare that was recorded on the 16th in the afternoon, evening times, because these things don't just happen in a quick flash. But yeah, they take hours to actually be observed, and things like that. So here we are. There's on the left, that was the last week on the 16th. And on the right, that is what the sun looks like today. As you can see, we've lost quite a few active regions, but as I said, it's been a record-breaking week, because on the over the 18th and 19th, we actually had 18 active regions on the face of the sun, and they literally covered it. So yeah, it was very, very big, and during that time, I think, what was it? We had something like 240 odd actual sunspots on the face of the sun, which again is record breaking. So yeah, it was. So we've had quite a lot of uh, active regions go across. They've been pretty poor in actually producing anything really strong in the way of solar flares. In fact, we had 125 flares, optical flares this week that were actually captured, that were counted. But again, we were in that position where there was a lot more action going on the far side. So yeah, we had 18 sunspot regions, and it was 275 sunspots, and we literally started from the 17th all the way through to today. Literally, we've been over the 200 sunspots every single day. So it's been a busy week, as in some in flares, but they've been very low. They've been C class or M class flares. I think over the week we've only had about two X class flares, but nothing really to write home about. So some of the stuff has been coming our way, but it's very weak, because a lot of these things aren't associated with CMEs. So it's just been rattling our cage and keeping us busy, keeping us active. So yeah, so the 18th and 19th we had the massive flares. The amount of active regions on there. There has been throughout the week lots of filament eruptions, filaments lifting off. The sun has been covered in lots of filaments. If you'd like to move on, Andy. So this here, this is the sunspots that we have on labeled today. And these are sort of like the bigger ones. So I think there's 9 here, as there should be 10. But as you can see, we've got 3 which have got some very intriguing magnetic stuff going on with them. Now, these letters, they refer to what the actual magnetic makeup of that active region is, what it's actually showing. Now, all these numbers, they do mean something, but I'm not going to go into them because I don't really understand. We're talking about monopoles, bipoles, and things like that. But what we're looking for is we're looking for the ones in red, because they're showing some very complex magnetic field action going on actually inside them. And the more that letters we've got, because all these letters can be singular, as you can see, we've got ABs, but we've got like 3762. We've got BGD, that's beta, gamma, delta. That's showing, and then underneath you've got 3761, which is showing a beta, gamma, and then at the bottom we've got again beta, gamma, delta complexity going on with inside the actual active region itself. The more letters we see in there, and because they're red, these are the ones that really we should be watching, because they could at any time give us something major. But we've had this all week, different regions coming. You can see some are stable, some are declining, but some are growing. These 2 at the top, 6.2 and 6.1, they're growing, so they could grow even more in complexity, and they could give us something later in the week. So if you'd like to move on, Andy. Oh, this is in this one here, this is what on the 18th and the 19th, you can see all those sunspots stretched across the actual sun itself. And they do vary in sort of like latitudes. So you know that most of them are sort of, especially in the bottom, the southern hemisphere, are along the equator line and the northern hemisphere, I suppose. But there seems to be quite a lot more away from higher latitudes, away from the equator in the southern hemisphere. But you can see some of them are quite big as well. So if we just move on, Andy. Hello. There we go. Oh, this should start at. Oh no, this is an image of that on the same day. We've showing all those regions spread across the actual sun itself, and you can see some of these filaments, these darker, straggly line areas that so a lot of them did actually sort of like lift off and things like that. So if we move on again, Andy, this should be a video. Is it going to start? No, it's not. That's great. I don't know why that hasn't started, because it should have started straight away. But again, this was again a 7-day video. Why it hasn't started, I don't know. You might as well move on to the next one, Andy, and that'll probably be the same, because this was a 48-hour video. Again, they're not starting. Can you click on them, see if they'll actually start, Andy?
No.
Just click on the screen. No, obviously not. So these were just showing some of the flares, some of the CMEs lifting off, and then why they're not playing, I do not know, because they played earlier on. And then sorry, mate.
A minute or so, I think I can fix this. Just talk amongst yourselves. Blah blah blah.
Yeah, blah 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 blah. But we have got some thing that we may be looking forward to, and some of it is actually tonight. We're expecting, because of some of these large filaments lifting off and a couple of flares that have gone off, not directly in the center, but they are Earth directed. There's supposed to be a hit coming tonight, and it's supposed to start about 11 o'clock-ish, and it's going to carry on into tomorrow. Tomorrow will be even more. Don't worry about it, Andy. Just if you want to go to the next slide, I can't remember which one it was now. If there was one.
1 second.
And then we'll yeah, again, this was it's a shame this didn't work, because early this morning there was a huge event that happened on the far side of the sun. And what happened was, in about the 8 o'clock region, if this had played, you would have seen there was a flare that came off from the actual rim. It was spreading out, and then all of a sudden from behind there was a massive explosion, which created literally a 360-degree halo. But it was all going away from us. And they reckoned that the actual event that caused this was an X4. Let me get this right. Originally they thought it was an X14. But when they've looked at the solar orbiter, which is on the far side at the moment, which was able to see this, using its STIX instruments, they reckon it was an X17 explosion, bigger ejection. And that's, like I said, it was if that had been pointing towards us in any form at all, we would have known about it. It would have really rattled our cage. So what I would just like to do, if you stop sharing that, Andy, I just want to pop this up.
Just 1 second. 1 second.
Okay.
1 second. There we are. Okay. This
it's working now.
Yeah. There we are. I'm a genius. There we are.
Yeah, well done. So this was the whole week. Now you can see the black things. That's when it's occulting behind the Earth, between the Earth's come between the sun and that. That is there where they're messing with the shutters. But you can actually see some of these flares lifting off. You can see some of these, not flares, filaments lifting off. You can see flares going off. You can see. Can we just get rid of the fingernails, Andy?
Just 1
that's
second.
all right. Don't worry about it.
It's all right.
So, there we go. Right. So, so you can see this going on. There are filaments lifting off all over the place. There's incidences going off all around. As Roger showed us earlier with his images, all around the rim, literally north, south, east, and west, there was something happening all week. Things were lifting off. There is an incident right in towards the middle up the north, where you can see there's a bright spot almost right in the center, just above the equator. That actually pops, and there's a big expulsion of material that comes off of that. You see a black cloud literally lift away from it. So I don't know if you want to try the other one, Andy. Here we are. This is 48 hours. It's this. I'm sure it's this region here. You will see it will flare, and then you might just see the actual material fly away from it. It's a bit bitty. It's a bit iffy. It doesn't want to know. So go on to the next one, Andy. We'll finish this off. Now this one, if you can get this one to work, as you said, you can see at the 8 o'clock. This now this is 2 seconds. I had to do this by hand, and you can see it coming out. Then all of a sudden, bang! You watch this. Here it goes. You can see it coming all from behind, but that is all away from us, and that has been measured by Solar Orbiter at an X17. And if that had been coming towards us, we would have been aurora galore.
Yeah.
As long as all the magnetism, that would have been that, and that would have probably lasted quite a few days. Because like I said, we've had all these flares going off. They've been coming towards us. A lot of them are missing us. We're catching the edges, but because they're coming in bang, 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 bang.
Yeah.
So they've kept our magnetosphere unstable, a bit rattly. So if anything does come along and they can clear out the area in between, we will see some aurora. So if I just look, the only thing is, and like I was saying, if I can bring this up, right, here we go. This is the Met Office. Now you should be able to see on a full screen. As you can see, this is the today. About 11 o'clock, they reckon this is all going to kick off, and then it will carry on into the early hours of tomorrow morning. It's a bit finicky. They don't leave it on large screen for very long. So there you go. So that's what you're going to be looking at. So come tomorrow, hopefully, or even later tonight, we may pick something up. But just look at it, listen out for your alerts. So we have got something coming towards us. What I can do is I'll Aurora watch. Yeah, as you can see, the KP is dropping anyway. So, but that doesn't mean that this is all over and done with, because the timings can be off by an hour or so, or even more. But just keep an ear out for your alerts and see if they go off, and hopefully then we might be able to pick something up. But yeah, so that's it then.
Okay. There we are.
Right. So let me just get rid of this.
Okay. So there we are. So thank you for that, Daz.
Yeah, sorry about that.
That's good.
Yeah. Okay then.
Right, so there we are. So an average week on the sun, apart from that X17, which could have been severely dangerous had it been aimed right at it. Yeah. I thought.
But there is, on the far side, there is still some more regions that are coming around again. So watch this way. Nothing's actually passed on, but of course, if we stay around the 200 marks, that means at the end of the month, that's the little graph I show you with all the sunspots, that is going to go back up again. It's got to. Sure. So there's quite a lot going on. So yeah.
Incidentally, I was reading that major solar storm that we had in May that produced those aurorae right around the world. Yeah, it also produced the most what am I trying to say? The most disturbances of satellite orbits. More satellites than ever were moved around by that solar storm. So not surprising. It was a new record. I mean, this is always a reflection of how many satellites there are in orbit, of course, because the more satellites you have in orbit, the more are likely to be deflected and have their orbits changed.
I mean, one of the things that they did know this was coming, and everybody was alerted, and everybody was able to do whatever they could to protect their satellites. As I said, the only main thing that I heard of is that SpaceX had downlink problems,
Yeah.
A lot of people just dropped out and things like that.
Mm.
But I didn't hear of anything actually crashing out of
No, I didn't.
the sky, because the atmosphere, as we've said before, it expands with all the extra energy and heat, which then means the lower orbiting satellites enter more of the atmosphere. They're passing through thicker atmosphere, relatively, if you know what I mean.
Mm.
But it's enough to actually slow them down, and then of course that will degrade their orbits if
Sure.
they can't push themselves back up
But God
into
knows
the danger orbit.
what an X-17 flare would have done straight at us. That would have been amazing.
Yeah, especially if it had a massive geomagnetic storm lined up with it, with a big,
Yeah,
like I say, a big CME.
we
Then
could have been in real trouble there. There we are.
we'll still be having the auroras a year later.
Yeah.
So
there we are. All right. Well, listen. Thank you, Daz, for that. As always, fantastic stuff. We're going to draw things to a close for the evening now. I'd like to thank all of the Space Oddities team, especially those that are here tonight, Roger and Daz and Michael and Lou. Especially big welcome, of course, to John. Hope it hasn't been too arduous for you, John.
Yeah.
Good man. So we hope to see you back, John.
Indeed, absolutely.
So we'll be back next week. Don't forget, we've got Brian Harvey of the pop group East 17 joining us next week. Well, it's a Brian Harvey, not that one. Brian Harvey's science author. He's authored over 20 books on spaceflight, with particular emphasis on spaceflight from Asian countries. So we shall look forward to welcome him on Space Oddities next week for a chat. Should be really interesting. Hope you can make it. Yeah. In the meantime, Daz has been a little busy bee. Daz has just produced a video on the channel about the life and work of Sir Fred Hoyle, which is really interesting. So if that appeals to you, go and watch the video on our channel, because as you may know, Fred Hoyle was an extremely controversial astronomer, well known for being the leading light in the steady state movement, with complete denial of the Big Bang. He was also heavily into panspermia. But of course, apart from all his eccentricities, he was the man who told us how the stars shine. So he will forever be remembered for that momentous work on nuclear synthesis in stars. So Daz has produced a video all about his life and work. If you would like to watch that, that's on the channel now.
I mean, it's a short video. It's a straight to the point video. If you wish to hear any more, because doing these when you research these people, you realise what fascinating lives they had. Then we can do another one at a later date, and we'll put some meat on the bones. And it was a very, very interesting character. Really was.
He was. And don't forget, viewers, if there's any particular astronomer or astrophysicist or cosmologist or whoever that you would like to know more about, tell us who, and we'll see if we can create a video for you.
Yeah, no problem at all.
So we're very happy to do that. And there will be another video coming up new on the channel within the next week, hopefully, all about Pluto. So I'm working on that one at the moment. So there we are. All right. Well, we'd like to say our viewers a big thank you. Please don't forget to like.
Thank you very much.
Thank you.
Been very generous as well. Thank you.
Yeah.
Generous. Thank you to Gerard and Ian for the donations this evening. Don't forget, viewers, you can use the super chat feature, which is the dollar symbol, to donate money to us directly, and it's all much appreciated, and it means that we can go on doing what we're doing, which of course we'd very much like to do for you. So thank you very much for being here. Look after each other. Have a fantastic week. We'll be back as usual at 8 o'clock next Tuesday, 8 o'clock UK time, 3 p.m. EST, for our chat with science writer Brian Harvey. So I hope you can make that. And in the meantime, it's goodbye from everybody here at Space Oddities, and have a fantastic week.
Good evening.
Thank you very much. All the best, and take care.
Thank you.
Excuse me 1 second. I can't get my mouse to work.
While you were doing that, then who was it? Somebody said that I should post the videos on Facebook and all that. Well, if there's anything interesting on, I usually do put up some videos in our Facebook page. So just keep an eye out there. And if there's any real decent alerts, I will endeavour to give you forewarning of any auroras that are on their way. So I do already put them up there. Thank you anyway. Thank you.
Right, just one moment. Just give me a second. I have a feeling that my mouse battery is dying. So I can't actually end the live stream at the moment. I'm replacing the battery in my mouse.
So
Another
another thing, Daz, you could put a link to your Fred Hoyle video on the Facebook group.
I think it's already there, isn't it?
Is it already there?
Oh, we'll have a look. Yeah, we'll have a look, and we'll see if there isn't. We'll put one up.
Yeah.
But as I said, it's a basics. If you want to hear some more about Fred, let us know, and we will produce a longer one for you. So.
Did you happen to mention the names of Cecilia Payne and Hans Bethe in your discussion?
No, I had in this, like I said, it's just a very basic video this time, but I had a Bondi, Mr. Gold, and Jocelyn Burnell, Bell Burnell. So there are a few of his cohorts that were mentioned along with him. But as I said, this was just a very bare bones, and if people want to know a bit more, then we can make a longer one, and we'll put some meat on the bones.
Yeah, definitely.
Sounds good.
And my mouse has gone completely haywire. Daz, do you have the end stream button at the top right of your screen?
End stream, yeah, I can do if you wish.
Yes, please. Okay, goodbye, viewers. We'll see you next week, hopefully. Have a great week.
See you later then.